Okay, hello everyone. I'm here with Matt Wood, who is the VP of Product for AWS. Welcome, Matt.
Thank you so much. Appreciate it.
So today we want to talk about how companies really maximize the value from data and machine learning and AI and all these exciting things. So maybe before we get into this, can you give us a brief overview of what you do? Because now you have a wider portfolio looking across the whole of AWS, but you really started in the data space and the ML space, right?
That's right. Yes, I joined AWS about 12 years ago. I was before that working on the Human Genome Project in Cambridge, where we were generating very, very large amounts of data and were struggling to process it in our existing data center. I had a friend of mine who had a similar life science background as myself, who worked over in Seattle, and emailed him and said, we're struggling with all this data volume. You've got all these different genomes that we were doing. We were doing human, we were doing mouse, we were doing duck-billed platypus, and we were slowly moving to doing multiple genomes for individuals and being able to sequence a genome for $100,000 in a week instead of billions of dollars in a decade. And so it totally changed the game in terms of what you could do with genomics, but also dramatically increased the amount of data that was being generated into the sort of tens or even hundreds of terabytes a week range. So I emailed my friend, and he's like, well, come to Seattle, have dinner with me. I'll tell you all about how other companies are doing this. I was like, there are very few people that I would fly halfway around the world to talk to and have dinner with, but he's one of them. Jumped on a flight, and as we were driving to the restaurant for dinner, he says, well, big news, I'm joining Amazon. And I was like, why are you joining a bookstore? It makes no sense to me. And over dinner, he talked to me about what would become AWS, talked to me about the opportunity for cloud computing, particularly as it pertained to processing, storing, and analyzing very, very large amounts of data. The opportunities for elastic storage and elastic compute and the databases that sit alongside them. And it was like a light bulb went off in my head. It was a blinding flash of the obvious. It was so clear to me then at that dinner table that basically the whole world would move to this sort of computing model. And so I flew back to Cambridge. We started to build some early genomics pipelines on AWS. And then I got a call, and 11 interviews later, I was on board as one of the early team members in Europe. I moved to Seattle about 10 years ago, and I've worked on pretty much every aspect of the business since then. I helped launch the machine learning team 6-7 years ago, helped grow that up. And I just took on a new role for me personally, and also a new role for us at AWS, where I'm looking at all of our products together and trying to bring the myriad of 270, maybe more now, certainly more over the next couple of days, services, and bring them together as a more cohesive set of capabilities instead of just a portfolio of services.
Very good. And we're at reInvent here in Las Vegas.
We are.
So there are some announcements around data, but before going into this, I'm really interested in looking back to see what you feel are some of the key milestones when it comes to the use of data and ML that you are really proud of.
Sure, yeah, that's a good question. I mean, there's certainly been a lot over the last decade or so. The arrival of the elastic compute cloud, the ability to be able to, at very, very low cost, without any upfront spend or commitment, be able to pull down as much compute capability and resources as you needed to solve a problem is just transformational. And the reason for that is with anything that you're doing that involves very, very large amounts of data, the infrastructure, the storage and the compute and the databases, it can become a bottleneck. It becomes a constraint. And it can actually end up being the kind of rate limiting step by which you can use that data. It becomes a constraint by which, literally a box you have to think within. And you find that you have to you end up answering questions that you think you can get away with answering based on the resources that you have available to you. And let's say you've got, not unusual, 100 petabytes of data, but you can only process a terabyte at a time. It's like 1/10,000% or something like that of the data that you can actually look at. And the answers you're going to get back are totally different than if you could look at everything together. But you have to operate that way because the constraints around you prevent you from answering the questions that are really on your mind. And so what the cloud does is those constraints melt away. And you end up being able to ask the questions and get answers that really matter to you and to your business and to your team, whatever it might be. And so the arrival of that delivery of computational resource as if it was delivered not in a huge mainframe that you had to buy and provision and rack and stack and maintain and all the rest of it with huge expense and time, but delivered at the end of an API, just totally transformational. Yeah. And so that utility delivery of computing, or utility style delivery of computing, just changed everything. And so from that model of utility computing delivered by experts from a large grid, with pay as you go, being able to pull down elastic capacity, we were able to build out at AWS a pretty robust, broad set of capabilities for dealing with data in very, very large volumes. It was so obvious early on that it was going to be one of the key areas that customers are going to want to use in the cloud. And today we have many, many customers who have not hundreds of petabytes, but exabytes of data stored in the cloud that they process all the time. So, and continuously. So I think one of the big advancements was probably the arrival of Amazon Aurora, which was a new MySQL and Postgres compatible database designed and built to operate in the cloud and really take advantage of all the elasticity and cost savings that I'm talking about. And you see pretty significant, between 3 and 5x performance improvements over the stock MySQL and Postgres engines at 1/10 the cost of commercial databases. And so it's those sorts of orders of magnitude shifts that you can enable if you design and build from the cloud. And so Aurora really helped customers adopt and store more transactional data. I think skipping forward probably only a couple of years, the next big advancement was Redshift, which I believe was the first announcement we made at the first or maybe the second reInvent. I think it was one or the other. And so it's been around for about a decade and it's just growing like crazy. Aurora is one of our fastest growing services, but Redshift is not far behind. And that's a data warehousing service. And so that allows you to not just look transaction by transaction, but look longitudinally across all your transactions, across your data. We've also added serverless modes to Redshift, so you don't have to manage the underlying infrastructure. You just click a few buttons and you get a data warehouse which is optimized for analytics. Skip forward another couple of years. I think the big piece is probably SageMaker, which is our machine learning service. It's designed for data scientists and builders of all capabilities to build, train, and deploy custom machine learning models. That's been incredibly popular with a very, very large number of customers. You saw some examples in the keynote this morning. I think all the customers said that they were using SageMaker, including for things like sustainability predictions and modeling and of wind turbines and all those sorts of things. So that proved to be another really big step forward. And then I think probably the thing that we're seeing this year is that these capabilities of storing transactional information and warehousing information, combining that with a data lake and machine learning capabilities it's getting closer and closer together. All machine learning relies on some level of analytics, which all relies on some level of data engineering. And so these areas are coalescing, the data engineering, the machine learning, and the data lake pieces are all coming together. And so what we announced this morning was some pretty meaningful improvements across all of these areas, which make it much, much easier for customers to be able to store, process, analyze, and build machine learning models on top of data at pretty much any scale.
So what are some of the highlights?
I think one of the big ones for me, I'm a fan of all of these, so I will try not to cherry pick. All my children are my favorite, but I'll go through some of the key ones. I think one of the big ones was the arrival of something we call Aurora Zero ETL integration. So what this allows you to do is to take that transactional data from Aurora and with a single click and close to real time to be able to make that data available inside Redshift for analysis. So up until today, you really had to do a lot of pipe work, a lot of data engineering work, a lot of extract, transform, and load work. And moving that from a transactional system to a data warehousing system, you have to do a lot of repetitive work, a lot of real undifferentiated heavy lifting. You have to build the scripts and make sure they're running and put them in the pipelines, and then you've got to fix them when they break. And every time you make a change, which will happen often at either end, you have to go update all your scripts. And so it quickly becomes a big kind of unsustainable black hole of work for customers. But today, all of that goes away, and you can now literally click a button in the management console for AWS and make that data from your Aurora tables move. It's about a second it takes to move from Aurora and be available for analysis inside Redshift. And so that just completely removes this enormous amount of work that was required and investment that was required from customers to do more with their data, and significantly increases the surface area of data that's available for analysis. So that's one. I think the other one would be, another one would be the introduction of Spark integration with Redshift. And so Spark is probably the most popular way of building big data applications. It's a high-performance way of building big distributed systems which can analyze lots of data. And we've added integration with Spark that you can now run from pretty much anywhere on AWS, including Athena or Elastic MapReduce. And you can now run those Spark queries directly against your data inside Redshift. So with these two capabilities, which are just two of about a dozen that we did today, we significantly increased the amount of data available for analysis and significantly reduced the kind of barrier of entry for working with that data. And those two things, again, remove some of those constraints that I was talking about before, just allowing customers to get the answers to their questions from the data much, much more quickly.
Very good. So what are some of the focus areas for AWS to help customers really maximize value from data?
That's a good question. So I think for sure, Redshift and the data warehousing piece, that's a big area of investment for us. It's really important making sure that runs with high performance, making sure it's easy to use, but also works really, really well with things like Spark, and it's easy to query that data from multiple sources and combine that data with data inside your data lake. So that brings all of that data together in a way that you can aggregate it a lot more easily. We're also looking at big investments inside SageMaker, particularly around managing very, very large volumes and complex models. SageMaker makes it so easy to build, train, and deploy models that customers have really taken advantage of that, and they now build not just one or two models, so they're in fine-tuning the models and getting them to work perfectly, but they've kind of industrialized the process using SageMaker, and they now train dozens, hundreds, thousands of models. And so with SageMaker, we're adding a large number of new capabilities which enable you to govern and manage those models at a much higher scale. So to be able to put roles around the models, to be able to determine who can do what with them from a governance perspective. We have a new detail page per model, which pulls together the model, the provenance, the accuracy, when it was last trained, the background to the model, all into a single place, so anybody that's looking at it can get a sense of what that model is going to do. And that allows you to drive much bigger, you drive more models and more usage of machine learning internally. I think that's going to be a big deal, whilst also improving the SageMaker Studio IDE, which is an integrated development environment for building machine learning models. So we've made that much easier to use. We've also introduced real-time collaboration. Very important with machine learning because you often have lots of different domains that want to work together, science, engineering, business domains. They all want to work together, and having them collaborate inside a notebook can be a very, very powerful way of doing that. And then the ability to be able to take a notebook and just execute it as a job and just run it over and over again. So again, that industrialization and flowing that through your governance systems is all very, very important. So that's machine learning. I also think we've got some just fantastic new capabilities coming up in terms of business intelligence. So business intelligence for most organizations is where the rubber really meets the road for data. It's where most less technical business users, product owners, executives get their key metrics about how the business is being operated that's flowed through that whole pipeline that I just talked about. And so we have a business intelligence service that we call QuickSight. We launched it at reInvent, I think, 7 years ago. It's doing fantastically well as a product. There's actually we're having a drinks meetup for our QuickSight customers later this week. And I had the opportunity to go last year. It's just an amazingly fun event. There's customers there. They're so passionate about QuickSight. They're opening up their laptops and showing off their dashboards to all their peers and other customers. So very exciting event. So we're adding some new capabilities there around a feature called Q. So Q allows you to ask natural language questions of data inside your data warehouse or data lake, whatever it might be. So instead of having to write SQL, you can just say, what were my sales last week? And Q will interpret that natural language. It will generate all the SQL on the background, go execute the query, and in usually less than a second, you'll get back either an answer or a relevant visualization that answers your question. Right. So it significantly reduces the effort required to go ask questions of your data, literally. But also, you don't have to have a data engineering team on hand to go build a new dashboard. You don't have to go design the visualization. You don't have to put it on a backlog or file a ticket for someone to pick up later on. Just ask a question, you get the answer, and you move on. So we're adding forecasting questions into Q. So you can say not just what were my sales last month or last week, but what will my sales be in a week's time? And we'll use machine learning under the hood to generate a real-time forecast of what your sales will be, including seasonality and everything else you'd expect in an accurate machine learning-driven forecast. And also importantly, why questions. So the data is very interesting, but customers often want to know, why did my sales go up last week? I saw this spike in the visualization, the graph went up, but why? What's driving it? And so QuickSight will actually go through and it'll identify the key contributors to that change, what contribution they made to the data, and that will allow you to refine your question or look at more data or even take an action to go talk to somebody and give them a pat on the back.
That is super cool. And will hopefully really democratize the use of data.
Exactly. Yeah, that's the idea.
To make this real then, have you got some customer examples that you can share with us that really highlight how some of these new technologies come to life and how they really add value?
Yeah, absolutely. I think one of the projects I've had the opportunity to work on has been a lot of fun. Has been working with some of our sports analytics. The World Cup's going on, so we've got it was only sport to talk about. So we've done a lot of work with soccer. We've done a lot of work with also Formula One. But the one that's really interesting, I think, has been around what we would call American football, and a lot of your viewers will just call football with the NFL here in the US. So we had an early discussion with the NFL, and they wanted to be able to use machine learning to drive more fan engagement. And so American sports in general, I've learned are really about judgment. It's like judging the players. Are the players overperforming or are they underperforming? And so we worked with the NFL and we came up with a series of what we call next-gen stats, where we're able to make in real time a prediction as to whether a specific pass, for example, will be completed successfully. And then you can tell, whether that player, if the pass is completed successfully, if the probability of that was low, that player is doing amazingly well. If it was high, they're just performing at spec, which is good to know as well. So we have a series of about a dozen next-gen stats, and the way that we generate these is we have a sensor in the ball we measure multiple times a second. We have sensors in the pads of the players, and we map the detection. We do pose estimation of the players. We also use computer vision systems from the broadcast cameras and pull all that together. We have about 24 machine learning models running inside SageMaker, which take all of that data together live as the game is being played, pipe it into the prediction system, generate the next-gen stat. That stat then goes to the production team, it gets wrapped into some graphics automatically, and also goes to the commentators so they can commentate about the next-gen stats as well. So we've got this really nice end-to-end system, which we needed to gather the data at the edge, process it, label it, generate the models, make sure they were working well from lots of different modalities, including the 3D, the cameras from multiple different angles, creating 3D pose estimation, doing collision detection, who's in a scrummage, who's got the ball. It's actually quite difficult to tell, even for humans, if you just look at how NFL players come together. Yeah. So that was pretty successful, but it was really the tip of the iceberg of what we ended up doing with the NFL. It was so successful that we started to look for other ways that we could use the partnership that we'd built up. And that partnership was actually really interesting and is a good model just in and of itself of one of the most important elements of machine learning. You can talk a lot about convolutional neural networks and generative models and all the technology, but successful uses of machine learning are only really 50% technology, and the other 50% is the culture and the collaboration that you can drive across domain experts, across technical experts, and bringing those groups together successfully. We learned a lot about how to do that we've been able to pass on to other customers. So based on the strength of what we've done with next-gen stats, we started to look for other areas that the NFL may want to apply machine learning. And we didn't have to brainstorm with them for very long at all before they wanted to address player health and safety.
Yeah.
How can we improve the safety of the game? How can we improve the safety of the players? And so we started to use some of our post-estimation techniques, and we started to use some biomechanical engineering models so that we could predict the stress and the strain on particular joints, and basically built digital athletes within the NFL. So elite athletes are kind of like Rolls-Royce cars. Like, there's a lot of them. They're very expensive, and so you can't just go smashing them into each other whenever you want because it's very inefficient. So with our models, we could play what-if games. We could see if you change the rules, if you change particular pass styles, if you change the coefficient of drag on the AstroTurf, how would the different players perform? What sort of stresses and strains would be put on their knee joints and on their elbows? What would be the likelihood if we change the helmet design of reducing the chance of a concussion? All those sorts of things. And so we were able to drive all of that using our machine learning models, our digital athletes, both with the NFL and a series of partners that could go off and actually design the safety gear and evaluate rule changes and all those sorts of things. So that's been a long-term project for us, but it's one which has been really impactful for the players in the game.
Yeah, great story. So you mentioned some of the learnings that you could share with other customers. Mm-hmm. What are the key ones there?
That's a good question. So I think on the technical side, there's a lot of learnings there. The easiest one to convey is to use SageMaker. It really does make a really big difference, and we've seen a lot of customers standardize all of their machine learning workflows on SageMaker. But on the cultural side, what's been interesting is helping customers evaluate where they should start on their machine learning journey. Machine learning can be a little counterintuitive. Things that appear kind of easy end up being very difficult. Things that you would assume are kind of difficult, like generating images and voice and all the rest of it, can actually turn out to be pretty tractable. And so we do a lot of work with customers in just helping them kind of evaluate where they should make a start with their machine learning investments. We kind of look at that in three different dimensions. So the first is, how ready is the data for analysis? If you're really honest with yourself, like, do we have data sets which are labeled or amenable to machine learning? And you can kind of do an inventory of that as an organization. Then the second one is kind of, is this a big business challenge? Like, if we solve this successfully, will it be a big deal? And the third one is, kind of the X factor. How likely do we think we'll be successful given the capabilities that we have, given the state of the art of machine learning? And if you score highly in those three dimensions, you can do those all day long. Very, very high chance you'll be successful. But you only really need 2 out of 3 to really take a good go at it. And so you can have data that's ready to be labeled. You can have a very capable data science team that's ready to go. But the business need, it's okay if that's low sometimes, because you can get some wins under your belt with the team with things that are kind of off the radar when there's very low blast radius. Conversely, you can have a capable data science team and you can have a really high business impact problem, but the data is maybe not available for analysis. That's great, because those two things will drive improvements in the data quality so that it is ready for analysis, and that's where you can make the investment. So if you've got 2 out of 3 of those 3 dimensions, then that's a pretty good indicator that you will be successful. If you've got 1 out of 3, this probably goes at the bottom of the priority list. But 2 out of 3, you can make a lot of progress with those.
Very good. Just very quickly, if you look into the future, what are your hopes for the future?
Oh, my hopes for the future: peace, love, understanding. But in the data space, I think I remain incredibly excited about these large foundational language models and image models. I think there's use cases where they can obviously be less successful. We've seen some examples of that, but largely I don't think we've really found the edges of the capabilities of these very, very large models, and they're going to get better. They have been getting better very, very much more, very, very quickly. They're getting very, very capable, and so being deliberate and thinking through where to apply those to the business challenges as a customer, that would be very high on my list of things to do over the Christmas vacation.
I agree. Thank you so much, Matt, for your
You're
time.
welcome. Appreciate
Thank
it.
you.
Thanks.
Anyone who wants to ever re-watch or re-listen to this, head to my YouTube channel or my podcast. Okay, see you soon.